Conditional probability is probability when events in the situation are dependent, so they're not independent events as we've seen. Here are some examples of dependent events, which are just events that affect one another. Studying hard and doing well in an exam. If you study hard, it doesn't guarantee you'll do well, but it really improves your chances. Practicing at chess and winning a chess match. Again, these are going to be dependent events. Eating less and losing weight. And then lastly, more of a exam-style example, taking a sweet from a jar without replacing it, and then getting the same kind of sweet when you take another from the jar. Well, if you have a sweet, if you eat the sweet from the jar, you're less likely to get that same type of sweet next time. So they are dependent events. The conditional probability of B given A is the probability of B happening given that A happens or has already happened. If A and B are dependent events, this will actually be different to the probability of B alone. If they're independent, then it doesn't matter. The probability of B given A is the same as the probability of B. But for dependent events, it's a little bit more subtle. So there's a special AND rule for dependent events. For dependent events A and B, the probability of A and B is the probability of A times the probability of B given A. You do need to know this technically, but I would say that in a question, it's easier just to look at the context and to work out the probabilities from there. But it is important to be aware of this. So as I said, most of the time at GCSE, it's much better to think sensibly about the situation instead of using the formula explicitly. Here's an example. So this is sampling without replacement. That's what it's called at GCSE. But again, if we just think sensibly about the situation, it shouldn't be too bad. So I've got a bag of 12 sweets, 4 are red, so probably strawberry, 3 are blue, and 5 are green. I take a sweet at random, I eat it, and then I take another sweet at random and presumably eat it. I want to work out the probability that I take a blue sweet and then I take a green sweet. So I'm going to write this as the probability of blue and green, so B and G. Now, we know that this is really probability of B times the probability of G given that B. But again, let's just think about this logically. What's the chance that I first take a blue sweet? Well, that's going to be 1, 2, 3 out of however many sweets I have, which is 12. And we generally think of as times, so I'm going to say times. And now I need to think of the probability of taking a green sweet after I have taken a blue sweet. Well, if I've taken a blue sweet, we can imagine, right, that blue sweet, for example, is gone. So now I have 1, 2, 3, 4, 5 green sweets, but only 11 sweets in total. So it's 5 out of 11. So I would say that my probability is 3 times 5, which is 15, over 12 times 11, which is 132. So my answer would be 15 out of 132. So I'll just write it up a little bit more neatly. You could simplify it to 5 over 44, but we don't generally simplify probabilities. B, what is the chance of taking a blue sweet and then another blue sweet? So in terms of notation, I'm going to write this as probability of B and B. Now, this isn't two identical events. This is the probability I take a blue and then I take another blue. So let's imagine the situation. Everything's back to normal now, so the sweets are all back as they were before. I take a blue sweet. The chance of that is 3 out of 12. I eat that blue sweet, so now I can imagine one of the blue sweets has gone. Now I'm in a new situation. I have 2 blue sweets, so I need to do times for and 2 blue sweets out of 11 sweets, which gives me an answer of 6 out of 132. So again, let's just write it up a little more neatly. And that's how we'd write it. Finally, I have to imagine now that I'm now taking 3 sweets in a row. So I take a blue sweet, then a green sweet, and then a red sweet. The chance that I do this is going to be the probability of blue, and then green, and then red. So I should put and, okay? So this is going to be, if I take a blue sweet first time, that's going to be 3 out of 12. Times, right, I've now taken a blue sweet out of the bag, so there's only 11 sweets left, and only 5 of them are green. And then times again for and again, I've now taken a green out of the bag, so there's only 10 sweets left, and 4 of them are red. So it would be that. And then if I calculate that, so let me just rub that out. We end up with a final answer of 1 out of 22, but generally you could just leave it as, in this case, 70 of 1,320. You could leave it like that, and that would be fine. Here's another example. So this time, a box contains 5 black balls, 7 white balls, and 2 grey balls. 2 balls are chosen at random without replacement. Find the probability of choosing 1 black ball and 1 grey ball. Now, I haven't specified this time if I'm taking a black ball then a grey ball, or a grey ball then a black ball. So we actually have to look at both events. So first of all, always start with words in probability. So I'm going to say I've got the probability of black and then grey, so B and G, or grey and then black. Remember, mutually exclusive events I can just add when I have the OR rule. Now, the chance of getting a black and a grey, that's mutually exclusive from getting a grey and a black. They're 2 completely different events, even though they've got the same probability potentially. So what I'm going to do is do black and grey. So imagine I take a black ball out of the bag. That's going to have probability 5 out of, right, let's work out the total. There are 14 balls in the bag, so that's 5 out of 14. So I've taken a black ball. The chance of now getting a grey ball is going to be 2 out of 13, because there were 13 balls left in the bag. Or means plus, so I'm now going to add, and now we need to think of it as a whole new situation. So what's the chance of getting a grey the first time around? 2 out of 14. And then getting a black is going to be 5, because there were 5 black balls, but there were only 13 balls because we've now taken a grey ball. So this is 5 times 2, which is 10, over 14 times 13, which is 182. And then we add, again, 2 times 5 is 10, over 14 times 13 is 182, which gives us a final answer of 20 over 182. Then question 2, find the probability that the 2 balls chosen will not be the same colour. So my method here is going to be to work out the probability that they will be the same colour, and then subtract this from 1, which is essentially the complement of the event. So first of all, let's work out the chance that they are going to be the same colour. So there are 3 possibilities, potentially. We have black and black. You could have a black ball, then another black ball. Or white and white. Or grey and grey. This represents the chance of getting 2 balls that are the same colour. Now the chance of getting black and then black is going to be 5 out of 14 times, well, if I've taken a black ball, there's only 4 black balls left and only 13 balls in the bag. So hopefully you should see how I'm doing this. So we're going to have 7/14 times 6/13. And then OR is plus 2 over 13 times 1 out of 13. And you should notice I'm not really getting hung up on the formula we talked about earlier. I'm just thinking sensibly. And I've made a mistake. 2 out of 14, my apologies, times 1 out of 13. My apologies there. Okay, so now we're going to calculate each of these. So we have 5 4s are 20. So 20 over 14 times 13, 182. plus 7 sixes are 42, 42 out of 182, plus 2 out of 182. Again, this is why I'm not simplifying. I can now just add the numerators of my fractions. 20 plus 42 plus 2 is 64. So I have a final answer, well, not a final answer, but I've got an intermediate answer, 64 over 182. And I now need to subtract this from 1. 1 take away 64 over 182 is going to be 182 over 182, that's just 1. Take away 64 over 182. 182 take away 64 is going to be 118. So I have a final answer of 118 out of 182. Here's a question for you to try. Please pause the video now and have a go, and when you're ready for the answer, press play. Here are the answers.